subtract the polynomials. 3x to the fifth minus 6x to the third minus 17 minus 20x to the third plus 8x to the fifth minus 8. The trick to subtracting polynomials is we really need to combine like terms ultimately, but before we do, the biggest secret is to turn each of these terms, each of the terms in the second polynomial, like we're taking the first polynomial and subtracting the second polynomial. We're going to take a view at these two polynomials as the first polynomial and the second polynomial. We're subtracting the second polynomial from the first. The trick is to turn each of the terms in the second polynomial to their opposites. That's how we look at the minus sign. So I would ask myself, what is the opposite of positive 20? I would say negative 20. I would come back here and say, what is the opposite of positive 8? I would say negative 8. What is the opposite of negative 8? We would say positive 8. Once we've changed all these to their opposites, which we just did, then subtraction becomes addition. Now we really just combine like terms. We look inside of the first polynomial and we try to identify unique terms. In other words, here's an x to the fifth power in the first polynomial. I carefully go over to the second polynomial and I go, is there a like term like x to the fifth in the second polynomial? And I say, yes, there is. Look, it's not the first term, it's the second. That's the next killer that we need to pay attention to. The like term for x to the fifth is this term, negative 8. Now it's negative 8. Negative 8x to the fifth. We copy this term underneath the other x to the fifth term in the first polynomial, and we would say negative 8x to the fifth. I'm going to align these for vertical subtraction. So I'm kind of thinking in like terms. You know, this x to the fifth term from the second polynomial, we moved it under the x to the fifth term in the first polynomial. I'm going to slash this negative 8x to the fifth out because it's been moved over here. So we want to keep track of as we move these. Now, here's x to the third power. Here's a term with x to the third power in it. We come over to the second polynomial and we identify that it does in fact have a like term with x to the third. So we're going to move this guy underneath its like term in the first polynomial, negative 20x to the third. And we're lining it up for vertical subtraction. I'm thinking in columns, you see. And just go back and check, negative 20x to the third, negative 20x to the third. Okay, I got it moved properly underneath the like term in the first polynomial. Now, we look at a constant term in the first polynomial. Sure enough, I find a constant term, and it's a positive 8. So we're going to move this positive 8 underneath its like term in the first polynomial and slash it out from the second one because it's over here now. So now we're switching to a vertical method of subtraction, and we're able to complete the problem. So we also are reminded of x to the fifth either added to or subtracted from x to the fifth. The exponents on the x's don't change when we add or subtract. So here's how I'm going to think of it. X to the fifth minus x to the fifth remains x to the fifth. I look now at their coefficients. This is a positive 3. That's like having $3. But the negative 8 coefficient is like owing somebody $3. Excuse me, owing somebody $8. Let me go back. This is like having $3. This is like owing $8. If I pay this person back all the 3 that I have, wouldn't I still owe them 5? We really subtract, but give it the sign of, if we owe more than we have, this has got to come out. We've got to come out owing, and owing money is a negative thing. Having money is a positive thing. Owing money is a negative thing. That's how we think when we add or subtract, essentially. Now, x to the third minus x to the third remains x to the third because the exponent on the variable doesn't change with addition or subtraction. Now these numbers, I owe somebody $6 or I owe somebody x to the 6x to the thirds, however you want to look at this, but I'm just thinking I can just think about the numbers like money. I owe somebody $6, I owe someone else $20. I really add those together because I owe somebody a total of $26. I owe two people a total of $26. Then we move on to the constants that don't have variables, and I say I owe somebody $17, but I can only pay them back 8. I only have 8 to pay back. What do? We subtract 8 from 17. It's like, what's the difference between what I owe and what I have? 17 minus 8 is 9. But look, I owe more than I have. I pay this person back all the 8 that I have. I still owe them $9. So in the end of this, we look for all of our terms. I'm just going to write it one time cleanly. Negative 5x to the fifth minus 26x to the third minus 9. And we come up to the answer choices, and I see that we're able to identify one term at a time. Negative 5x to the fifth. I might do this problem by identifying every one of the answers that have negative 5x to the fifth in it. Then I'm going to come over to negative 26x to the third. Answer A has a negative 26x to the third. So does answer D. And then the last term I find is a negative 9 in our answer, and the only one of these that has all three components that are correct is answer D. So we choose the correct answer choice.